Let me explain it the way I'd explain it to Morty. First, you have to import the package. After the import is complete, make sure you can see both the streaming assets folder and the GRU folder in the assets folder. The streaming assets folder is required because it contains the test bookshop database. Without this folder, the demo scene nor the unit test will work. I know it's tempting to place these folders elsewhere, but for the love of God, please don't do it manually. If you move them manually, the GRU will just get confused and start throwing up errors. Trust me on this one. Just use the configuration window instead. Click on Tools, Medium Interactive. Configure in the Unity toolbar. The package folder path is where you want to keep the GRU core folder, while the integration folder path is where you want GRU to keep automatically generate database repositories and database contexts. If you want to keep the default folder structure, just click on the Create Configuration button. But if you want to keep your third-party assets in a separate folder, then click Set Package Path and select a folder where you want GRU to move its core folder to. Personally, I like to move the GRU core folder to the folder called third-party assets or external dependencies, where I keep all my third-party assets, and the integration folder to the folder called integration folder. It took 3 nanoseconds for my neurons to generate this idea in my prefrontal cortex. Once you've set the path you want, click Create Configuration and GRU will begin migrating the folders and creating the jump package. You can also update the paths later if you want to. After configuration, the next step is to create your first database. You'll notice that the Create Database menu is now enabled in the toolbar. But since you don't have any tables yet, let's create them first. GRU supports the code-first approach to database creation, which means that the tables in the database are created based on the code. Each table in the database corresponds to exactly one C# class in the Unity project. If you look at the demo bookstore scene, you'll see that the color class corresponds to the color tables. Similarly, the book class corresponds to the book table in the database. By the way, I would recommend installing either the database browser or the database schema. GRU supports integration with these popular programs directly from the Unity editor. They are useful for querying the database using SQL and generally for visualizing relationships between entities. I'm not sponsoring them in any way. They're just useful tools, not as useful as a portal gun. Oh no, well you get what I mean. Okay, back to where we were. Let's go through the process of database creation using the inventory database as an example. We will have only 3 tables: item table, an inventory table, and a table called inventory item, which tells us which item was stored in which inventory. Always remember that your table class must have an empty constructor, it must be serializable, and it must inherit from entity base and aggregate root. If you forget even one of these 3 things, you'll get an error when creating or updating the database. Entity base is a base class that contains the primary key and some other columns that every table should have, such as a created at datetime column. Aggregate root is an interface borrowed from domain-driven design. Google it if you want to know more. Now that we've applied this to all 3 classes, it's time to set column constraints and set up the foreign keys. Column constraints are set using attributes in the code. You can find a detailed list in the user manual in the documentation folder. For example, if you want a column in your database to be not null, you simply use a not null attribute of the property that represents that column. For foreign keys, naming is important. For each foreign key property, you must have a corresponding virtual property of a type that the foreign key represents. Again, if that is not clear from watching this video, then refer to the user manual in the documentation folder or check out one of the many code examples in the GRU unit test. And see, in this example, my inventory item table has a foreign key to the ID column in the item table, and a foreign key to the ID column in the inventory table. An inventory can have many different items, and an item can be found in many different inventories. In other words, this is an example of a many-to-many relationship. If you need to create a one-to-many relationship, you can do it this way. For example, in Bookshop's demo database, a book can have one author but many different co-authors, hence the collection. In the co-authors class, we can see that each co-author corresponds to exactly one book and exactly one author. The reason it's so important to set up these foreign key relationships correctly is that you can then use the include and then include methods to dynamically populate these entity properties. For example, you could say book.include co-authors, and you will get a book entity with all its co-authors pro-populated. Okay, once we have done that for all 3 classes, we can create our inventory database. In the Create Database window, enter the name of your database and select the tables you want to include in the database. There's built-in validation logic. So if you see that the Create button is disabled, just hover over it to read the validation message that appears in a tooltip. For example, you can't create a database with a name that's already taken by another database. When you're ready, click the Create button. It creates a database with the name you specify, the database repositories, the class and the interfaces, the database context class, and it saves it in your integration folder. You can also update the database later using the Update Database window if you want to put additional tables. Note that deleting tables or changing foreign keys isn't currently supported. You can now see that in the streaming assets folder is the inventory database. If I right-click on it and open it in the DB browser, you can see that all tables have been successfully created. Finally, we connect to our database from the code in your consume class. You just need to add a reference to the database handler and instantiate a new repo instance based on what you want to query. For example, if you want to query the inventory table because you want a list of all inventories, you create a new inventory repo instance. Furthermore, you want to be able to add new items to the item table. You would also instantiate a new item repo instance. Don't forget to assign the DB handler instance and the DB handler slot in your scene. This tells GRU which DB context to use, since it inherently supports simultaneous communication with several different databases. Never delete this DB handler game object from the scene manually. Always use the delete function in the update database window. Now, just for testing, we will add some data to our database. Let's create a couple of items, a couple of inventories, and then we'll connect the two. After I start my game, I should be able to see the items I just created in the item table, as well as inventories that I created in the inventory table and the data in the inventory item table. I will have to wrap things up for today, but before I go, I will give you a few examples of the most commonly used CRUD queries. First of all, the query methods get, update, delete, and create were already covered by the repo-based class, from which every repo extends. And since the repo classes were automatically generated and set up by GRU, you can already use them without having to write a single line of code. The add method is used to create new rows in the table. The add range method is used to add a list of entities at once. Without it, you'd have to include the add method in your for loops. The update method updates the past entity, while the remove method deletes it. Delete range is used to delete the list of entities. You can think of it like the add range method. Look for the delete action. Get all method fetches all entities in the table, and get method fetches the entity by ID. Find by is useful when you want to find a single entity that matches your query predicate. While find all by is useful when you expect a list of rows that match your query. For more complex queries, you'll need to add a separate method in the repo. Let's say I want to query all inventories that contain a particular item. For that, I need to create a separate method called get all inventories with item and the logic to the code, and only then can I use it. You can find more details examples in the user manual in the documentation folder. How does a penguin build a house? It glues it together. Like us, it's an automated driven by blind genetic constraints, slowly marching towards oblivion. But with GRU, that marching might be less painful. Yeah, baby.